In this class, I'm going to talk about inductor. Inductor is nothing but a simple a simple conductor made into coils. Okay, so if you take a conductor, current carrying conductor, okay, that is made into a coil. So this is called an inductor, a simple conducting wire. If you make it into loops, make it number of loops, then it become a inductor. We know that for every conductor, um, every conductor is going to have some resistance. That resistance R equal to rho L by A. L is the length of the conductor, A is area of the conductor. So most of the conductors are round conductors, A equal to pi r square. Rho is called resistivity. Resistivity is nothing but what kind of material it is, like aluminum material, copper conductor, aluminum conductor, silver conductor, or carbon conductor. Those are all the conducting materials. Now, so for sure every conductor is going to have some resistance, so it is impossible to have a pure, I don't want to say impossible, but it's really hard to have a pure inductor. Okay, I believe MRI machines use, they produce lots of magnetic field. So, and wherever you see resistance produce heat or light, and MRI machines doesn't want to, a person is going to go inside, so we don't want to see lots of heat in there. So most probably those MRI machines might have a pure inductor. But wherever you see a regular inductor in electrical purposes or electrical machines, for sure they have some resistance, because most of the electrical machines are made with copper conductor, and copper has some resistivity. Now this inductance value L equal to, inductor we indicate with the L measured in Henry. Now this L value, L equal to mu naught n square A times L. I'm not going to use this formula. This formula is from physics. We're not going to use it to solve any example in this course. But I want you to know what is L, or how to find L. L is nothing but mu naught n square A times L. N equal to number of turns. How many turns are there? 100 turn, 50 turn, whatever it is. A is area of the loop. What is this area? Area of the loop. Area of the loop. L is nothing but length of the inductor. L is nothing but length of the inductor. Okay, and mu naught is called permittivity of free space. Permittivity of free space. So basically it's a constant. This value is 4 pi times 10 to the power of 4 pi times 10 to the power of minus 7 Tesla meter per ampere. Okay. As I mentioned, we're not going to use this formula anymore, but I just want you to know how to make a inductor. Take a conducting material, copper conductor, make it into number of loops. It's going to act like a inductor. Similar to capacitor, this inductor is also have a property. That first property is, these two are the important properties. It stores energy in the form of magnetic field. So if you remember, capacitor, it stores energy in the form of electric field. Here it stores energy in the form of magnetic field. That value is half L I square. Job. Okay. Another important point is inductor, it opposes rate of change of current. so it won't let the current change suddenly across an inductor. um, these are the basic things about the inductor. So you have to remember these two things: it stores energy in the form of magnetic field, and it opposes the rate of change of current. And inductor equal to L equal to mu naught n square A times L. It's nothing but a conductor made into number of loops, made it as a coil. Now the voltage drop across inductor equal to so plus minus VL, or sometimes we call it as E, indicated with E. That's called induced EMF. E equal to L times di by dt. So the voltage drop across inductor equal to L times di by dt. Probably you may need to remember this formula to the voltage drop across inductor.